So this particular example today is using quite a famous reaction, which is for the Haber process, which is a process for making ammonia from nitrogen and hydrogen gas. So we're going to begin with actually working out the mass of ammonia generated during this reaction, then working out the percentage yield, and then the atom economy, and then we can discuss what these results actually mean. Before we start, make sure you have your calculator to hand, your periodic table, and the 3-point process that I've attached below in the description, or you may have had from one of my previous videos. And let's begin. So calculate the mass of ammonia that can be made from 12 grams of hydrogen. First thing I'm going to do is circle the two things that are discussed in the question, and it asks about ammonia that can be formed from 12 grams of hydrogen. So in the 3-point process for working out the mass of something being formed, it says step 1, circle the two things discussed in the question, and work out the moles using the information given for one of the substances. So we can see we're given the information on hydrogen. So moles equals mass over RFM. The mass is 12. The RFM of hydrogen gas is 2. 1 plus 1 is 2, is 6 moles. Step 2 in the process says, now that you have the moles required, what is the molar ratio? Is it 1 to 1, 2 to 2, 5 to 4? Well, you can see that the molar ratio is 3 to 2 in this case. So if I want to work out the moles of ammonia, I need to divide my previous answer by 3 and then times it by 2. So 3 to 2 ratio. Therefore, 6 divided by 3, and then we times that by 2. So 4 moles of ammonia is the amount of product we make. And finally, step 3, it says, now that you have the moles required, work out what is asked for in the question. So the question asks for the mass of ammonia. So we do mass equals moles times RFM. The moles is 4. The RFM of ammonia is 14 for nitrogen plus 3 times hydrogen is 3. So that's 17. So it's 4 times 17 gives us an answer of 68 grams. In theory, we should make 68 grams. So this is what's called the theoretical amount. That is how much we should be generating from 12 grams of hydrogen reacting. Now this sets up the next bit, which is percentage yield. So percentage yield is, I'm just going to write it just as a word equation, really, is quite simply the amount obtained, whether that's in grams, kilograms, moles, divided by the theoretical amount, and times it by 100 to turn it into a percentage. So in other words, it's the amount you get in the experiment divided by the amount you should have got times 100. It'll be 20.3 is the amount that was actually obtained in the experiment. Theoretically, we should have had 68. So we times that by 100, and it's 20.3 divided 68 gives us a percentage of 29 point, it says 8529, so 25.9%. So just under 30%. So ask yourself this, is that a good yield? Well, not particularly. So we should be getting 68 grams, we're only getting 20.3, so only 30% yield, which is pretty poor. So you may ask yourself, well, what is the point in proceeding with this reaction if we're only making a 30% yield? Isn't that wasteful? You know, why persist with something that has such a poor yield? Well, this is where atom economy comes in. The atom economy is defined as, so AE is equal to the RFM of desired product divided by the total amount of product times 100. It's not dealing with masses in grams or kilograms or moles. It's actually just the RFMs of the molecules being produced. And if you're producing more than one of that molecule, so in this case you can see we're actually making 2, that's what I've underlined in green there, then yes, that you have to include that, so it'd be 2 lots of ammonia. So let's work out this atom economy. So we can see that the atom economy is, the desired product is ammonia, so it's 2 times 17 divided by the total amount of product. Well, here's the thing. If you look at this product, there's only one product there. There's ammonia. There's no waste products. Otherwise, they would be included in the equation. So it's just going to be 2 times 17 divided by 2 times 17 times 100 gives you 100%. So this particular reaction has 100% atom economy. Even though the percentage yield is really quite poor, 100% of the reactant atoms end up as useful product. So that is why atom economy is a much better measure of how efficient a reaction is or how successful a process is, because it looks at what reactants, which are in this case the hydrogen and the nitrogen, which I've just underlined, actually end up as useful product rather than going to waste products like, perhaps water or sulfur dioxide or carbon dioxide, like in other sort of organic reactions. All of those reactant atoms end up as useful product, and there is zero waste. So even though the yield is quite poor, it's worth persisting with this reaction, because even though you get a small amount, 100% of it is useful. And that is why atom economy is generally a better thing to consider when compared against percentage yield. Please check out all the other videos I've made on molar calculations. There's quite a lot there for you to get through, and I'm sure you're going to find some benefit from them in your studies at science at high school and beyond. Like, subscribe, and I really appreciate you watching. See you in the next one.